Welcome to our project, the Turntable Timeline. Team presentation. Meet the team. We are Alexandria Green, Parama Ghosh, Addison Moore, and Elijah Budrasang. We are Group 18. Our problem statement is to commemorate the 150th anniversary of Purdue Engineering. The College of Engineering is seeking an innovative, interactive, scale replica of a campus landmark honoring the past and future of engineering at Purdue University. The answer must be student and visitor friendly, symbolize one of the sesquicentennial themes, and be appropriate for public display on campus. It should be accessible, secure, and reliable for users of varying abilities, and also affordable, no more than $5,000, and technologically feasible based on materials and technologies that are available or readily accessible.
The first solution that our team came up with is the slingshot. The slingshot is meant to be a spin-off of the iconic game of Angry Birds. The slingshot that we would use would shoot out Purdue Pete instead of a bird and hit various Purdue landmarks. It is easy for all ages and even easier to recognize, but the main issue that the game would face is honoring the legacy of each landmark. Our second solution was Starship Fields. Starship Fields is inspired by many of the food delivery robots around campus. But instead of food inside the robot, it would contain the iconic Ross-Ade Stadium. Users would also be able to play a short football game, and fun facts would come out as they played. With Starship Fields, it would be easy to move around as it can move on its own.
Our final solution, or the one we went with, is the Turntable Timeline. This will take users back in time on a journey through the history of the beloved Purdue University. It ranges from the athletics department to our historic figures, such as Amelia Earhart and Neil Armstrong, then concludes with the current state of the university. In the middle of the turntable, the projector, a short video will be displayed, providing users with a visual look into the history and changes. Once the video ends, the last sound users hear is the bell tower chime, signifying that they're back in the year 2025. We modeled our project after Mackey Arena, and we will also have an interior portion. However, the timeline will encompass the exterior of our project.
Now that we have covered what our final solution is, let's talk about why we chose it. To this, we have to go over how it works, how it was tested, does it meet the criteria and constraints, what were the limitations, and the references for our data. So let's first talk about how our design works. As mentioned earlier, our design uses a turning table to move our timeline. To do this, the visitor first presses a button prompting the timeline to begin to move. From here, it begins to rotate on its own, showing major events in Purdue history. The user is able to stop and start the move at any time so they can interact with the events that interest them the most and learn more about these events from Purdue history. But let's talk about the criteria and constraints. Our design engages the user, letting them have interaction with the project through the button so they can engage with the aspects they want to. It also meets the themes provided and is safe for all users to use. Our design is easy to maintain and remains within the budget, having materials that are easily accessible to the public. We tested this prototype by surveying students' opinions on what they think of the project, if they would engage with it, and other aspects like that. To test more physical aspects, we created a CAD model that we used to base our calculations on, testing the materials, how they would be able to maintain, their durability, and the price point. From here, we found that some of the limitations we faced were limited interactivity, only being that single button for the users to interact with. We also found that as we began to scale up our design, the price also increased by a lot, getting close to the $5,000 budget. Our references for this, as mentioned, are just the survey results from various students around campus, some being from engineering, some being from other classes, and our CAD model test results.